won't hurt to go over it again. Got 5/6 over 7/8. 5/6 over 7/8 means 5/6 times divided by 7/8, which is 5/6 times 8/7. Okay, well, we could write this as 5 over 7 times 8 over 6. And we see that 8 and 6 are both divisible by 2. So we divide the 8 and the 6 by 2 and we get 4/3. So we have 5/7 times 4/3, and that's 20 over 21. Now, people do not and will not understand the rules for cancellation. That's something you should understand from the courses you've had before. So I don't like to use it, but here's what it looks like. We got 5/6 times 8/7. We realize that 6 can be divided by 2 and 8 can be divided by 2. So we divide by 2 and we get 3 here and 4 here. It gives us 5 times 4 over 3 times 7, which is 20 over 20. Same thing we got here. We can even go back to this, to this. We can take the 5/6 times 8/7 and just multiply it up. 5 times 8 is 40, 6 times 7 is 42. And then we can write 40 as 2 times 20 and 42 as 2 times 21. We could also do the prime factorization, but this is going to be sufficient because the 2 divides the 2, and we end up with 20 over 21. So there's 3 ways to understand what happened here. Okay, down here, we got 2/3 plus 1/4 divided by 3/4 minus 1/3. We need to add these fractions and we need to add these fractions. So we put them over common denominator. Now there's another alternative that I guess I'm probably going to show you in a minute. But let's just put these over the common denominator. And the common denominator with 3 and 4 is 12. We should understand that from the stuff we did very early in the course, like the first week, when we reviewed fractions. So if you don't understand that stuff, go back and you need to review it. Okay, so anyhow, our 2/3 can be multiplied by 4 over 4, and that gives us a common denominator. That gives us a denominator of 12. If we multiply the 1/4 by 3 over 3, it gives us a common denominator of 12. Of course, we have to multiply the numerator and denominator by the same number in each case, or we change the value of the fraction. Okay, well, down here we do the same thing. We're going to have a common denominator again of 12. We're going to have to multiply 4 by 3 to get a denominator of 12. So we multiply 3/4 by 3 over 3. And we have to multiply this 3 by 4 to get a denominator of 12. So we multiply this fraction by 4 over 4. The result is 2/3 times 12 over 4. Multiply the numerators, we get 8. Multiply these numerators, we get 12. Multiply these numerators, we get 3. Multiply these denominators, we get 12. I think they called this a numerator. Don't listen to what I'm saying. So anyhow, we get 8/12 plus 3/12. So the same thing with the denominator. We get 9/12 minus 4/12. Well, then 8 and 3 is 11. Same denominator. The denominator stays the same. If we got the same denominator, we can just add numerators. We get 11 over 12. Here we add the numerators. Actually, it's a subtraction. 9 minus 4 gives us 5. 5 over 12. So we have 11/12 over 5/12, which now means 11/12 divided by 5/12, which means 11/12 times 12/5. And we can write it out. This numerator would be 12 times 11. The denominator would be 12 times 5. 12 divides 12 and gives us 1. We're just left with 11 over 5. There is one other alternative here, and it's actually, I think, the most efficient alternative. In this case, and never mind, it doesn't happen all the time. Somebody will tell you about it, but I don't want to confuse the issue. Make sure we understand this. Okay, this goes back, the addition of fractions and subtraction goes back to what we did in the first week. So if you have to review that, review it. We're going to need to understand the operations with fractions because very soon we're going to do the same operations with symbols without numbers. Okay, and that's not going to be as much of a challenge if you understand how the numbers work. All right. Okay, so let me ask you to do another one. We're going to use, I said we're going to be doing this with symbols. We're going to dive right into that. Okay. Let's take this. What's your first step? How do you multiply fractions? Okay, so after a couple of glitches, we see that this is equal to 2 times 5 divided by 3 times 7, which is 10 over 21. There are no common factors in 10 and 21. 10 is 2 times 5. 21 is 3 times 7. None of the factors in the numerator match any of the factors in the denominator, so we can't simplify this. Okay, so now what do you think you're going to do with this? You're going to do exactly the same thing, except you've got to recognize it. Okay, so what do we do to multiply this? Some people got it, some people didn't. If we multiply the numerator here is x plus 2, and that has to be multiplied by the numerator here. Of course, we have to put parentheses around this because if you don't, you're not going to be multiplying the whole numerator by anything. So you got to multiply the whole numerator here by the whole numerator here. And that's going to give you this. And then you do the same with the denominators. You multiply the denominator by the denominator. It's no different with symbols than it is with numbers. In other words, the rule both times is you multiply the numerators and multiply the denominators, okay? There it is. Now, of course, we then use the distributive law to multiply these. Same thing we did here, we do here. It's just that here we have x's in our expressions. And we might have a much more than that. You might have much more complicated expressions, but it doesn't matter. We're going to multiply numerator by numerator divided by denominator times denominator. Now we have to do the multiplication. So we apply the distributive law, which I spent some time working on this, and we've explained it. So I'm going to refer to it just kind of briefly. X plus 2 times something is x times that something plus 2 times that something. There's your distributive law of multiplication over addition. We do the same thing with the denominators. Okay. And we're not done because we have to use a distributive law again. Multiply x by x plus 3. Well, we got x times x. And we get x times 3. And then we get 2 times x. And 2 times 3. And then in the denominator, x times x plus 5 is x times x plus x times 5 minus 4 times x and minus 4 times 5. Then we know what to do. The x times x becomes x squared. X times 3, we're going to write as 3x. 2 times x, we'll write as 2x. And 2 times 3 is 4, 6. Denominator is going to be x squared plus 5x minus 4x minus 20. And then the 3x and the 2x can be added. And the 5x and the minus 4x can be combined and give us that. Okay. And here we have it. It turns out that in this case, the numerator factors and the denominator factors. So we would go on and write this as or 2 times x plus 3 over x plus 5 times x minus 4. Now, why do we bother doing this? Because if one of these factors in the denominator was the same as one of the factors in the numerator, we could divide it out. Okay. So turns out not to be the case. So either this or this, excuse me, is a valid result. Okay. How does it distribute along? Use distributive law on the numerator, use it on the denominator. Since to do x times x for x squared is 0. But now you have to have x times negative 5, which would be a negative 5x, and you don't have a negative 5x. Okay? So if you did this, this is going to match. this would be x squared minus 5 times x because it is distributed. Okay. And similarly, so you can't factor that x. If there's an x on 5, okay. So that's not going to work. You're just going to have to use the distributive law. What that is. Okay, so people got the right idea on this, but you want to be careful you don't do anything that's invalid. Okay, so what this means is you multiply the numerators and you multiply the denominators. It's going to give you x squared minus 5 times x plus 4 over x plus 3 times x squared minus 2. Well, it's going to be a little more complicated, but we're going to use the distributive law. Now, we're going to do just like what I did here, except, of course, this is an x squared. So x squared minus 5 multiplied by this is x squared times x times x plus 4 minus 5 times x plus 4. And we divide that by x times x squared minus 2 minus plus 3 times x squared minus 2. Okay, this minus this times this is this times this minus this times this. Same thing here. Pattern of the distributive law, which you should probably go back and review. You have assignments on that. So you need to make sure you understand the distributive law. In any case, we have this. Okay, so we use the distributive law again. X squared multiplied by x plus 4 is x squared times x plus x squared times 4. And then we have minus 5 times x and minus 5 times 4. We divide that down here. X times x squared minus x times 2. And then it's plus 3 times x squared and minus 3 times 2. Now we can write x squared times x, that's x to the third. And we have 4x squared minus 5x minus 20. The denominator, x times x squared gives us x cubed. X times 2 is 2 times x, so minus 2x. 3 times x squared is 3x squared minus 6. And then we will want to write the 3x squared before the minus 2x because we want to write these terms in decreasing powers of x in the form of a polynomial. I don't have room to write that out, so I'll just say, well, we're going to interchange these two. We're just going to put the 3x squared over here and the minus 2x here. At that point, we might try to factor this thing. There's a good chance that it doesn't factor in any reasonable way. So, you know, usually we end up leaving it like this, but sometimes we check out the factorability. That's something you'll see in pre-calculus, but we're not going to cover it in the support portion. Okay. Okay. Well, that's how we multiply fractional expressions, okay? The rule is very simple. You multiply the numerator by the numerator and the denominator by the denominator. That's all there is to it. And then, of course, you got to use the rules to simplify what you get. And the main rule is going to be your distributive law. Okay. Now, it's a little tougher to add these things. Dividing isn't bad. You just do the reciprocal and multiply. I don't think you'll have any trouble with that as long as you remember that division is multiplication by the reciprocal. But the one thing that gives almost everybody trouble is when you try to add these two. So let's say you got x plus 2 over x minus 4 added to x minus 5 over x plus 3. Well, how do you add fractions? When you add fractions, you first find a common denominator. Okay? So we find a common denominator. In this case, it's easy. It's going to be x minus 4 times x plus 3. So we want to change the form of these fractions so they both have denominator x minus 4 times x plus 3. How do we do that? We have x plus 2 over x minus 4, and we're going to multiply it by a fraction whose denominator is x plus 3, because then our denominator will be x minus 4 times x plus 3. Now, we can't just multiply by like 1 over x plus 3 because we would change its value. If we multiply by x plus 3 over x plus 3, we're just essentially multiplying it by 1. And that's not going to change its value. Now, you do want to be a little bit careful. We have restriction on the domain and so forth. We're not going to talk about that. We're going to focus on the mechanics of doing this thing, and then later we'll worry about domains. Okay, so this is equal to this. Okay, because all we've done is we've taken this here and we've multiplied it by something that's equal to 1. It doesn't change its value. Okay, then we have x minus 5 over x plus 3. And we want to get a denominator of x minus 4 times x plus 3. We're going to multiply that by x minus 4 over x minus 4. Again, just multiplying this fraction by 1 so we don't change its value. But now that we've done this, our denominator is x minus 4 times x plus 3. Each of them has the same denominator. So this equals this. And we just multiply numerators and multiply denominators. And then we have multiply the numerators, x minus 5 times x minus 4. I'm going to change the order of multiplication here, but that doesn't change the result. I'll write my x minus 4 first, and then my x plus 3, which is exactly the same as x plus 3 times x minus 4. It doesn't matter what order we multiply things. So now we have the same denominator, and we can add the numerators. Just like adding fractions with numbers. We add the numerators and put those over the common denominator. There it is. Now there's more. We can multiply these out, add them up. There's an et cetera involved here, but let's just concentrate on getting this step done. Because once this step is done, if you know how to use the distributive law and simplify these expressions, you're not going to have any trouble. Okay. And if you don't know, well, you're going to have to learn. You're going to have to go back and review assignments. You didn't quite pick up on. But here we have it. Okay. So let me give you another one. Let's say you got they got this. Go ahead and do find your common denominator. Take this step and see how far you can go with it. Okay. You done pretty well with this one. I keep telling people, find your common denominator. This reinforces the fact that you need to find a common denominator. Or just imitate what you see. Make sure you understand what you're doing. Okay. Find the common denominator here. So now we multiply x minus 2 over x minus 6, and people have this step correct. By x minus 5 over x minus 5, which is a multiplication by 1. Doesn't change the value, just changes the way it looks. Then it's plus x plus 3 over x minus 5. We're going to multiply that by x minus 6 over x minus 6, so that our denominators here and here are going to be equal. Okay, so we get this equals this. Now we multiply the numerators out. I'm not going to go through the details of the distributive law. We'll write it out. But the details are the same as here, and you don't need to be skipping the details at this point, because you need to reinforce the distributive law. People lose track of the distributive law if you don't use it explicitly every chance you get. And then we have x plus 3. Well, x plus 3 times x minus 6, x squared minus 3x minus 18. And we divide that again by x minus 5 times x minus 6, but I'll write it in the reverse order, x minus 6 times x minus 5. Now we have the same denominator, so we can add numerators. X squared minus 7x plus 10 plus x squared minus 3x minus 18 divided by x minus 6 times x minus 5. Now, x squareds, we have an x squared and an x squared, which gives us 2x squared. We have a minus 7x and a minus 3x. Excuse me, that gives us minus 10x. And then 10 minus 18, well, that's minus 18. And we divide that by the denominator. We're going to keep the denominator factor. X minus 6 times x minus 5. And then we check the numerator to see if it can be factored. Turns out that it can't. So I'm not going to get into the details of checking this, but it's possible that this could factor down into a product of two terms, and one of the terms could be an x minus 6 or an x minus 5. It's not going to happen, but it could. Not going to happen in this case. So that's how you add fraction expressions. Okay. Okay, now when you're confronted with a function like this that you want to graph, you start by finding its y-intercept. Okay, so can you find the y-intercept of this function? Okay, now I spent a lot of effort trying to get people to understand that the y-intercept occurs when x equals 0. That's automatic. When you see y-intercept, you think x equals 0 because the y-axis, or on the y-axis, the x-coordinate is 0. Okay, so the y-intercept is y equals g of 0. 0 plus 2 times 0 minus 3 times 0 plus 5. And you multiply that out, and you get -30. Now you can sketch a graph of it. Don't mark a bunch of points on a graph. You don't know how many points you're going to need. Okay. You can do this. You say, okay, well, y is going to be -30, so I better have -30 here. So this is the point, this is a line for y equals -30, and here's the y-intercept. Okay. Now find the x-intercepts. And maybe it's just one intercept, maybe it's more than one. How do you find the x-intercepts? Well, write something down. Write what you think we need to know in order to find the x-intercepts. We automatically say we find the intercept. So the first thing you do is find the y-intercept. X equals 0 at the y-intercept. So y is what you get when you plug in x equals 0, which is -30. Find the x-intercepts. Okay, the x-intercepts. Y equals 0. So 0 equals x plus 2 times x minus 3 times x plus 5. Thus, x equals -2 because that makes x plus 2 0. Or x equals 5. No, this should be 3. X equals 3, or x equals -5. Okay, so we find the x-intercept. X equals -5 out to x equals 3. We'll put x equals -5 about here. And we'll put x equals 3 here. And x equals -2. We'll go about here. Y is 0, so we have this point, and this point. Okay. That's how we start. We find the x-intercepts. We find the y-intercepts. I want you to review this. If I ask you this in a quiz next time, it's not going to be in the homework just yet, but it's coming up in a week. But I want you to get used to this much, because once you've done this, The rest is relatively easy. Okay? Turns out, if what you do, and I don't want you to do this because you won't understand it just yet, but what you do is you just draw a curve. These points look something like that. Got to go through all these points from left to right. Now, why do you start low and end up high? We're going to talk about that later. But first, I really want you to get it into your head that when you graph anything, you're going to find the x-intercepts, you're going to find the y-intercept, okay? And you write that down so that you keep reinforcing it so that you understand it, so that you'll do it when you need to, okay? So there we have it.